Okay, let's be real for a second. Have you ever stared at a folder on your computer and seen files named project_final, project_final_final, or maybe the classic project_final_v2_actual_final? Yeah, we've all been there. It's the messy, chaotic way we usually try to save our work. Now imagine collaborating on a single document with 3 friends at the exact same time, without a system in place. Someone accidentally overrides your paragraph and boom, your hard work is just gone. Well, welcome to this explainer where we are going to solve that universal panic once and for all. Today, our main goal is to completely demystify Git and GitHub. If you're a beginner in programming or tech in general, you really need to know that these tools are absolutely foundational. We're going to take what often looks like an intimidating wall of command line jargon and turn it into an accessible, everyday superpower. By the end of this explainer, you'll understand exactly how developers track their code history, restore previous versions, and collaborate safely. Here's our roadmap for today. First, we'll look at the version control solution. Then, we'll compare Git versus GitHub. After that, we'll walk through local Git workflow steps, followed by cloud collaboration on GitHub, and finally, a real-world team scenario. Let's dive right into Section 1, the version control solution, and why we need it.
So, the answer to our chaotic folder problem? It's a version control system. This isn't just some basic backup tool. Honestly, it's like a foolproof automatic time machine for your code. Think back to working on that shared document with your friends. A version control system acts like a perfectly organized ledger that secretly records exactly who made what change and exactly when they made it. If a mistake happens, you don't need to panic. You simply rewind to a previous version. It literally eliminates the fear of breaking your project because your original code is perfectly protected.
Moving right along to Section 2, Git versus GitHub, and understanding the tools. Now, you might be wondering, aren't these the exact same thing? Beginners frequently conflate these two tools, but they're entirely different beasts. Git is the actual engine running on your own computer. It's your local version control system managing the files right there on your hard drive. GitHub, on the other hand, is the cloud network hosting your Git repositories online. So a great way to think of it is to picture Git as the camera app taking a photo on your phone, and GitHub as the social media platform where you actually upload that photo so all your friends can see, comment, and interact with it. Let's look at how this plays out locally on your machine. Say you start a brand new project. Boom. Commit 1, your initial setup is locked in. You do some work, add a brilliant new feature, and you save that as commit 2. Later on, you squash a really annoying bug, and that becomes commit 3. Instead of messy V2 or V3 files cluttering your desktop, you now have a perfect chronological timeline of your project's history. Every single step is tracked. And the best part? If something completely breaks in commit 3, you can effortlessly jump right back to commit 2. Let's move to Section 3, local Git workflow steps and the terminal commands you'll use. Okay, so how do we actually do this? Well, these 4 steps are the foundation of your local Git workflow. First, you type git init in your terminal. This initializes a brand new, completely empty Git repository right in your project folder. Next, you can use git status at any time to check which files have been modified. Once you're ready to save, you use git add dot to stage your files. That's essentially you telling Git, hey, get these ready to be saved. Finally, you use git commit -m followed by a descriptive message, like initial commit, that locks your work into the timeline. Congratulations, you've officially saved a version of your code. But what if you want to experiment with a crazy new idea without breaking your main project? That is where branching comes in. By using git branch and git checkout, you create and switch to an alternate timeline. It's literally the ultimate sandbox where you can code fearlessly without affecting the main project at all. You can make all the commits you want in this separate branch. Then, once your crazy new feature is working perfectly, you just use git merge to seamlessly blend that experimental branch right back into your main codebase.
Next up is Section 4, cloud collaboration on GitHub.
So the crucial point here is that connecting your local Git engine to the GitHub cloud opens up incredible teamwork possibilities. First, you create a repository on GitHub and clone it, which basically means downloading a copy to your local machine. Then, just like we learned, you make and commit your changes locally. When you're ready to share your genius with the world, you push those changes up to GitHub. Finally, instead of just forcing your code into the main project, you open what's called a pull request. Think of this as a peer review for your code. Your team can look at it, discuss the changes collaboratively, and once everyone gives it the thumbs up, it gets merged into the main project online.
Let's see this in action in Section 5, a real-world team scenario. Let's move to a practical example and see how this builds. Imagine a team of 3 developers building an e-commerce site simultaneously. Developer A is handling the front end, pushing UI updates. Developer B is on the back end, setting up API routing. And Developer C is managing the database schema design. Without version control, this would be an absolute nightmare of overwritten files and lost work. But with Git and GitHub, they divide the labor perfectly. Each developer creates their own isolated branch to tackle their specific task, completely avoiding stepping on anyone else's toes.
And here is the climax of their workflow. After creating branches and making commits to save their progress, they push their branches to GitHub and open those pull requests. Now what happens if 2 developers accidentally edit the exact same line of code in different branches? When they try to merge, GitHub throws a merge conflict. Sounds like time to panic, right? Not at all. Git intelligently highlights exactly where the conflicting code is, pausing the merge so the team can manually review and choose the best code to keep. They easily resolve the conflict, merge the final code, and pop the champagne for the successful deployment of their site.
Ultimately, what you should take away from this is that GitHub is much more than just a storage locker for your code. It's a living, breathing, professional portfolio. It provides a highly reliable cloud platform for your Git repositories, enabling that seamless team collaboration we just talked about. Plus, it gives you access to millions of open source projects. By pushing your code to GitHub, you are actively building a public resume. When you apply for an internship or a software development job, recruiters absolutely want to see your GitHub repository to witness firsthand how you write, manage, and collaborate on code. So, to wrap things up, Git manages your version history locally, and GitHub stores and shares it online. Together, they make collaboration effortless and professional. So, here's my final question for you. Are you going to finally stop saving your files as project_final_v2 and start building your professional portfolio with Git today? The absolute best way to learn this is by doing, so practice these commands daily. Next time, we'll be ready to dive even deeper into advanced branching and cloud collaboration. Thanks for joining me for this explainer.